Hey guys, welcome back to Study with Sri. Today we are going to continue with the further calculus series which we are studying these days. The previous video we have discussed about integration by substitution. It was so fun and we have done some questions as well. You can, if you haven't watched that video, you can watch it again, and then if you still have any doubts, you can write your doubts in the comments so I can explain your doubts in a video. So today we're gonna go with the integration by substitution. So here, let's say you should understand, whenever you are doing integration, remember integration is just the reverse of differentiation. In the differentiation, you have a different techniques and you have some precise methods to solve a different differentiation. But when it comes to integration, it's just you have to find out the pattern. You just have to visually find out the pattern and then identify the methods to solve it. So there is no like for a specific integration, okay, this is the only method. It's not like that. So you just have to find out, you have to figure out the pattern, and with the practice you can improve the integration by parts. You can improve the integration, but one of the step is integration by parts. One of the pattern is integration by part. So for example, now in this case, just see, if you are trying to integrate x multiplied by e to the power 2x, see, if you try any other methods that so far we have studied, it would be kind of difficult for you to integrate it, because if you look out this, it looks scary, because you might be thinking, okay, let's integrate these things separately and then multiply them. No, you can't do that. Just like the differentiation that has a product rule, for the product in the integration, we have a separate, very interesting technique, and that technique is known as integration by parts. So far we know, when we talk about the integration by parts, or else when we talk about the integration, we know it's a reverse of differentiation. So even for the integration by parts also, it's gonna be come up with the reverse of differentiation. Let's try to understand. For example, if you have studied properly the differentiation, you know one thing called the differentiation of products. So you will be doing the product rule. You will be applying the product rule when you are trying to solve the differentiation. When you are trying to solve the differentiation of the product. For example, there are two functions, which a function u with respect to x and another function v which is respect to x, means the differentiation of u times v with respect to x, according to product rule, you can write u into dv over dx is equals v into du over dx. This is, precisely. Now what we are going to do is, I'm going to come up with the integration by parts formula from the product rule of differentiation. So in this case, what we are going to do is, we're gonna cross multiply this dx. We're gonna cross multiply this dx into the other side. So I can write du of v is equals u dv over dx into dx plus v du over dx into dx. What I have done here is, I just have multiplied this dx, I have cross multiplied this dx either side. Now simply I am going to integrate either side. So now tell me, what is the integration of duv? So this is for some students, for some reasons they have a difficulties to integrate duv. They don't have a conceptual idea. They just you might be just going through some patterns, but make sure you understand it properly. So if I go with the integration, very simply, the very simple idea of the integration, is, you just have to understand. Simply you take a line. Let's think about this line. If I say this line is x, if you are chopping this line into infinitely smaller part, that is the differentiation. Differentiation is you are just finding out the smallest part of it, and that smallest part is dx. Simply the differentiation is finding out that smallest part for this line because it's not having a slope. The integration is summing up the smaller dx part again. If you sum up the smaller dx part again, you will be getting the x again. So chopping this x into smallest particle is going to be dx, and in summing up this dx is going to be x. So that's the fundamental idea of differentiation and integration. That's a very interesting idea. So if you know that idea, it would be very easy for you to conceptually think, or else you can think about the context. When we integrate the duv, it's going to be simply uv. Then I can write u dv over dx. To make it easier, I'm just writing as v prime. dv over dx is I'm just writing as a v prime. It's an integral part. And then I can write dv over dx part, I'm just writing as a v prime. And this one I'm writing it as v into u prime. So now from here so what I have written is I have integrated duv, I got uv, and then either side I'm just integrating. So dv over dx I'm just writing it as a v prime. du over dx I'm writing it as a u prime. Now the simple technique that we are going to use it, I'm going to subject any of this term. So let me subject this guy, which is u into v prime. It's interesting. Then you can write u times v minus v into u prime. Wow, we got an idea. We got a beautiful formula of integration by part. So how did we get this integration by parts? Simply from the product rule of differentiation. As I said, integration is simply the reverse of differentiation. So it's going to be very interesting. It's going to be very fun. So when you're practicing these questions, because now if you want to integrate these things, either you can give to ChatGPT or else you can give to the calculators, and they will probably giving you the answer. But you are trying to think these and you are trying to understand these patterns, that is kind of really helpful for your brain. There are a lot of wirings and lot of neuroplasticity that will help you, that will improve your decision making and your cognitive thinking and your critical thinking. So it's always fun to do the math. Whether you are a student or else whether you are studying maths for fun, it's always fun. Maths is always fun. So now we have a formula which is integration by parts. Now that scary question, we initially saw this question, this scary question. Let's try to solve this. So shall we solve this question by the integration by parts? It's very simple. So simply you're gonna substitute this and get the answer. So you're gonna integrate x multiplied by e to the power 2x. So here what we are going to do is same thing, a very simple thing. You can choose someone as u and you can choose someone as a v prime. So let me give you a trick to choose which is u, which is v prime. So is there any method or is there any order that we have to think about? A simple thing is, comparatively differentiation is like differentiation, there are precise methods, so you can simply differentiate it. You don't want to think a lot. But then integration, you should need or else you should find out the pattern, and you just have to figure out the patterns. So I would say for the whichever part you have to integrate, let's say this is v prime. If you choose this guy as a v prime, then you should be able to integrate this. You find out which is easier to integrate and which is easier to differentiate. Based on that, you choose the u and v. So for example, in this case, integrating e to the power 2x is easier. Integrating x also easier, and then differentiating either of these also going to be easier. So for me, just let me choose this one as a u, and let's take this one as a v prime, because if you are choosing one guy as a u and other one is v prime, so u v prime. So now we can write, when you are writing u as a x, let's try to find out all the things that we have to substitute. You need u, you need v, you need u, v and u prime. So you need all these things. So you have got u and you have got v prime. Find out the u prime and v. It is easier. So what I am going to do is, u is x, so u prime, the differentiation of x with respect to x is 1, and your v prime is e to the power 2x. Integration of v prime is v, which is half e to the power 2x. And if you have difficulties to integrate this, please revise the integration by substitution, and this is very simple method. Now just since you have got all these values, just plug these values and you will be fine with the answer. So what you need, u is x, and what's your v? V is half e to the power 2x minus, what's your v? Your v is half e to the power 2x into, what's your u prime? Your u prime is simply 1. Now the simple idea, you can write it as half x e to the power 2x. You can bring this minus half, you can bring this half, which is the constant again. Integral of e to the power 2x, which we have already studied, integral of e to the power 2x is half into e to the power 2x, but never forget the constant. Now it's very simple, half x e to the power 2x minus 1/4 e to the power 2x plus c. Even though this question, it was initially appearing very scary, but now it's very simple. So this is the idea of integral by parts. Simply you just figure out the pattern, substitute, and you will be fine with the answer. So, and if you still don't understand, and if you have any difficulties, you can try a lot of questions, and then if you feel any difficulties, or if you find any difficult questions, you can come up with your doubts in the comment section, and we will be discussing those doubts in the next class and the next session. So now let's try another question, one more question. Let's try some interesting question. For example, let's say you are going to integrate x multiplied by ln x. So this is also a little scary, because this is kind of two variables are multiplying together. So whenever you have this multiplying part, always think about, okay, I was using the product rule in the differentiation, so now I should be using the reverse of product rule. It's integral by part, or it's the integration by parts. Simple. And I told you, like when you are choosing u and v, because you should be remember, u into v prime is equals to uv minus this u become u prime and v prime become v. So now we have to choose which is our u and which is our v prime. I told you, whichever is easier for you to integrate, you take that one as a v prime. So I'm gonna take u as an ln x, because integrating ln x is little difficult. Not difficult, but I'm just saying comparatively it's difficult. So I'm choosing this one as a v prime. So u is ln x, so u prime is going to be 1 over x. So v prime is x, v is going to be simply x squared by 2. Now if this is fine, now you have got this you got u prime, v prime and v. You can simply substitute these things and you will be getting your answer. So what are you going to do? So u and v, what's your u? It's ln x, and what's your v? It's x squared by 2 minus, what's your u prime? That's 1 over x, and what's your v? That we have half x squared. Now simply solve it. It's gonna be half x squared ln x you can bring this off out. X cancel, you just have x and dx. Integration of x is simply x square by 2. Never forget the constant, it's very important. So now just simplify of x square ln x minus 1/4 x square plus c. That's simple. So this is very simple and very interesting. So these questions are so fun, integral by part. So you try these questions and practice a lot of questions, and if you have any doubts, you can write your doubts in the comment section. And if you find this video useful and helpful, please share and subscribe this channel. And then if you find any difficult portions in mathematics, you can always write your doubts in the comment section. And we will meet with integration with the use of partial fraction in the next video of the further calculus, and then we will go to the differential calculus. So this is very interesting idea, which is integration by part. And if you find this video useful, please click the like button and then please share with your friends.